Is this milk matter? Well, yeah. Yesterday we found out that milk is anything that has a volume and a mass. So it's taking up space and it's weighing a little bit. And milk is actually mostly water, which is hydrogen and oxygen. And actually, if we add a little bit of vinegar to this milk, we can see those elements start to separate. Remember, elements are just ingredients that make up everything in the universe, because everything in the universe is made of matter. We can see that the milk is starting to chunk up. So we know that there's hydrogen and oxygen, because most of milk is water, but we also know that there's a little bit of magnesium and a little bit of calcium. Those are different elements. The reason all matter looks so different and acts so different is because it's made of one or more of these elements, and each element is different. Behind me is the periodic table, and today we're going to learn how to read one. So, for example, you'll see these big numbers, you'll also see these other numbers, and you'll also see a bunch of letters. I'm going to tell you what they look like. So the first thing we're going to do is write an example of a periodic square for carbon. As you can see, there's a 6 on the top, which is the atomic number, and there's 12.01, which is the atomic mass. The atomic number represents the most important part of an atom, which is the proton. The protons decide what the element is going to be. So go ahead and write atomic number is the number of protons. Each square on the periodic table also tells us the atomic mass. If I remember from yesterday, electrons are teeny tiny, so those don't weigh anything. So the only thing left to weigh are the protons and the neutrons. And that's the atomic mass. Today, we're just going to practice looking at one of these squares and deciding how many protons, how many neutrons, how many electrons. Protons, electrons, neutrons. Let's take a look with neon. First, we're going to write down our strategy steps. Step 1, we know that the protons are already the atomic number. Those protons are the most important part. That's the atomic number. Step 2, the electrons equal the protons. Remember, if electrons are negative and protons are positive, they have to cancel each other out. The good guys always equal the bad guys. Good guys, protons, equals the bad guys, electrons. Our last step is to find the neutrons. Well, we already have a number that tells us how much it weighs, and we know the electrons don't count. So our neutrons are actually our atomic mass minus the number of protons. So those are our strategy steps. Now let's apply it to neon. On the left side of strategy steps, go ahead and write down your atomic square. That's a 10, neon, and 20.18. First, we got to think about the protons. Well, protons are the most important. They call the shot. So that's our atomic number, is like our jersey number. So neon would have a number of 10. So number of protons equals 10. The next thing that's easy to find, step 2, is electrons. We know that we have 10 protons, the good guys, so we need to have 10 electrons, the bad guys. Our next step is the hardest. We need to find the neutrons. So this number, again, is our atomic mass, and it tells us the big heavy things, the protons and neutrons. If I've already used up 10 protons, and I know I have about 20 in my atomic mass, well then I know that I need 10 neutrons. So I take my atomic mass, which was rounded to 20, minus the 10 protons, and I get 10 neutrons. We're going to show you one more example, and then you guys are going to do the rest on your own. Here's your atomic square. You should have identified the atomic number was 11, and so that's the number of protons. That's positive. If we have 11 protons, good guys, well, we must have 11 neutrons. Sorry, 11 electrons. Bad guys. Last thing we need to think about. Our atomic mass is 22.99. That number is going to round to 23. What does the atomic mass represent again? The atomic mass represents the protons and neutrons. So if I know that I need 23 in my atomic mass, and I already used up 11, I just need to subtract to find my neutrons. You can also look at your strategy steps from your notes. Your neutrons is 23, because we rounded our atomic mass up. Then we took away 11 protons, so we have 12 neutrons. That was a really quick preview. You're going to do one more on your own as your CFU, and then we'll come together and practice as a group.